Now, do you typically work from home, or are you just home for the holidays?
I do. I am up to our New York and Boston offices quite frequently, though. And luckily, the company's grown. I used to have to go overseas quite a bit, but this past year we've expanded. So we have New York, New York, Boston, London. I'm in the Washington, D.C. area, actually. And so the European team has expanded greatly, and I haven't had to go over there in about 6 months.
So that's exciting for you, right?
Mhm.
No, you get to be not living in an airplane or out of a suitcase, which is.
Most of the time.
But the industry itself is booming, and you guys get to do stuff that was like science fiction, 2 decades ago with the scanning and the biometric security and authentication. Can you tell me a little bit about the company, its name, and what it does?
So Veridium, and I'm the Chief Technology Officer. So we have a biometric authentication platform. And it is a end-to-end solution that is handling authentication, right? Proving your identity to typically what's a relying party is technically called, but right, when you log into a website and you use your biometrics. And we work cross devices, so that's the other exciting thing is we can use things like Face ID, Touch ID on those particular phones, but we also have modalities that work across phones. That's really what's successful. And I guess the last thing is the ability of the platform to plug into existing architectures, existing identity access management solutions. Active Directory, the Citrix platform, that was a must, right? So when we say end-to-end, we really mean it. Mobile to server, authentication and identity verification, and across platforms or across the devices.
So you have this platform, and you can work with all of these different devices and manage all the security.
That's right. So, I mean, it's one of the reasons I joined the company. As you said, biometrics, I'm not a biometric scientist by training.
You're not? Oh.
No. We have experts that are much better than me. No, I'm a computer scientist by training, more of a software architect. That's actually where I worked in. But, biometrics were kind of science fiction. I don't know what your first experience was, but mine were when you went into some place and they had those little single-digit fingerprint readers hooked up by USB, right?
Mm-hmm.
Okay. Those have been around for, maybe 20 years or so. Before that, rolled fingerprint and ink or something, but some of the slap scanners they're called. But they were highly proprietary. Well, they are highly proprietary, right? Each company, you have to have their software. So there really was no standard. So as these roll out, what was science fiction, what was really proprietary, is now becoming standards are rolling out for them, right? And have rolled out for them for security purposes, for privacy purposes, and for interoperability. So that's one of the reasons I joined, was I said, okay, this stuff is finally breaking out of the onesie twosie solutions, right? And if people are going to start talking standards, devices will be able to interoperate. So that's, essentially how I got involved and very excited about the platform solution.
And so this was, you've had an amazing career, right? Xerox, NASA. You were even a teacher at West Virginia.
Oh, you've been reading my bio. Yes, that's correct.
Yes, I have.
Yep. So many of my students, they're out there, tenured faculty at West Virginia University. Yes, that was an exciting time.
So tell me a little bit about what you were doing along this journey from, I'm really curious about what you're working on at Xerox. We had a couple people that were working on, I had a guest on the show, and he was working in the Xerox labs, and he had written the algorithm for the momentum with the mouse. As you move the mouse across the screen, it moves faster.
So Doug Engelbart's team. So So on my confessions on my resume, it says Xerox Corporation, Palo Alto, California. Totally true. However, I was just, if you put my age there, a lowly, just graduated with my bachelor's degree. So they don't put those people at Xerox PARC, right? But next door to PARC, they were trying to commercialize the PARC technology and sell workstations. Now in 1985, so my age here, the Star workstation, you can look this up, the Star workstation, the low end unit in 1985 dollars cost $40,000.
Oh my goodness.
And it had gray screen monitor, drag and drop email, WYSIWYG document editing. This is all. So I was on the part of the team, you know, as a programmer, essentially commercializing. The language was Mesa, right?
Wow.
Precursor to Ada. Anyway, so I was on the Xerox Office Business Systems Unit team there, and then I went back to do graduate school. And Xerox had a program actually that they were reaching out to universities. Unfortunately, that $40,000 a week workstation essentially had a 20 meg disk that would crash once a month. But it had Etherneted services, file server, print server. There was no mainframe in that system. It was really historic, but we had a saying at Xerox, you can tell we're the pioneers because we're the ones with the arrows in our backs.
I like that.
And I was never there when Steve Jobs supposedly came through and saw all this stuff and decided to do it for less than 5,000. But that was how the story goes. You know, it was great. It opened up my eyes. I had the pleasure to work with a wonderful man, if I may go on and on here.
Yes, please.
So my advisor at Maryland eventually left with tenure, the university position, Mark Weiser. So many people will remember a guy named Mark Weiser. Mark was my mentor and advisor until he left to head up Xerox's research lab. And Mark's idea that won him several awards was ubiquitous computing. And in ubiquitous computing, they did a lot of work on this. The computing will meld, and I'm going to segue back to biometrics here. Computing will meld into the background, right? So just like you would pick up a pen or a pencil, I could actually pick up your tablet computer and then authenticate and get my information. Your wall might be active, right? And the most fascinating thing was he said the same phenomena that's happening now with computing technology happened with print 500 years ago. People were enamored with books. They went around and bragged to each other about books, right? But eventually print melded into the background. Now, one of the key technologies to ubiquitous computing is how would you authenticate, right? When you went to somebody's wall in their house or picked up their tablet, right? You wouldn't do that now, right? We find these devices to be personal. Well, Mark found that to be an anathema. He said that that's not how it should work. You should be able to, the world should be open to you, right? That was the concept of ubiquitous computing, and we're totally not there yet. But to do that, you need to authenticate. You need to authenticate strongly and conveniently, right? So part of my journey has been, you know, trying to really realize Mark's vision. He passed away in 1999, unfortunately, at the age of 54. He really would have loved what's going on today and really been one of the leaders. Eric Schmidt of Google worked under him at Xerox PARC, actually.
Oh, really?
Oh, yeah, seriously. So I remember walking through the lab and seeing Eric Schmidt's door, actually, when he was still at PARC. So, so anyway, there's the long answer there.
I'm just like fascinated. I'm like listening to stories over here. This is amazing.
Right.
So then, did you tell me about NASA?
So my problem has been, I like computer technology. We are so lucky to live at this time. Imagine all of human history, and we are now computing technology, which is fundamental. It's fundamental as writing is on the scene and evolving rapidly, right? So it's very exciting being alive during the sliver of time. People like Alan Turing, right, but they would have even thrived more during this particular time. So I've been unable to focus on a particular job because I like lots of different things as they crop up. You know, I'm more of a, I'm gonna say a Renaissance person, but I have difficulty focusing on some of the trends. So I tend to look at computing across things. So that's what drew me to biometrics, the next challenge, you know, the next mountain that I think is going to be exciting because, I mean, identity and authentication are really broken. I mean, how many passwords do we have? Password reset rules.
Come on, though. Hold on a second. I'm gonna challenge you.
Nightmare, please.
I like this little thing right here. My phone opens to me, sees my face. I'm loving it.
Well, that's what I'm talking about. You now have another convenient option other than passwords.
I wish everything could just look at my face and just like, I don't ever want to enter. Nobody, you find in life that the innovation happens where people like want to be lazy, right? Mm-hmm. It's like, let's save me some time. Like, let's do it. Entering the amount of time humans spend authenticating is absurd.
Yeah.
Like, no. It should just, the world should just work for me and only me.
Well, and this was Mark's vision with ubiquitous computing, right?
Yeah.
So the rest of your listeners here, I would urge you go to Scientific American, September 1991. Okay, and the name of Mark's article was "The Computer of the 21st Century." That was the title of the article by Mark Weiser and his team at Xerox in 1991, and that's exactly what Mark said. Okay. The computer shouldn't be, you know, the focus of your attention. When people first got books, they ran around and bragged to their friends about books. Now it integrates into our life, into the background of our life, right? Okay.
Look at my new iPhone.
Yeah,
that's what we're doing. It's a new book.
But exactly, people are bragging about this now, and that's what happened when books first came out. They were so unique, right? But I laugh all the time when we go around and we show these devices, but they are a means to living our lives, right? They should be invisible. And part of what you just said, biometrics are that bridge to making it convenient and making the computer invisible, as Mark said in 91. So,
well, it's happening too, because like, for example, let's take a look at my phone here. It's a cute little monkey on there. She's 16 months old, right?
I have two myself. Yep.
Nice. And then you see the 24-hour time frame. It's all my phone, all my data. Well, this thing goes clunk. I go to Apple, put in my Apple ID. Boop. I don't care about the physical device itself.
So you're making Mark's point. You've got to read this article, Joel, because it says you should be able to pick up someone else's device or replacement device as easy as I would lend you my pen, right?
You're my best friend now. That's a zebra.
Oh, really? Okay.
That's my favorite pen.
Oh, mine too. So, but the idea, you get it, right? You should not be tied. Mark, and I hate to echo him all the time, but he always echoes in my head through my life. He was very influential. The concept of a personal computer, a personal device, was an anathema to the way Mark was thinking about the world, right? The computer should get out of your way. It obviously is helping you, but out of your way, as you're saying, the time we spend, time is one of the most valuable things here, right? And password resets, and even so, I think we're experiencing now this with second factor and multi-factor authentication, right? Certainly a super positive for security, right? Particularly, people are now using biometric authentication, not just for primary like you, but also for secondary authentication. That's where we hit the marketplace, right? Coming in for second and multi-factor, but ultimately moving to replace things like passwords completely, right? And to use your face, fingerprint, to do primary authentication, to get the computer, as Mark said, with ubiquitous computing out of the way. Yeah.
How do we why isn't there some sort of, I'm an engineer by trade, right?
Mm-hmm.
So why isn't there some sort of API style layer? No one's connected the dots where like my Mac has a camera on it. And when that multi-factor authentication comes through, like it should just bounce right off my face, just like it can unlock my computer. Why do I have to type in those silly codes all the time?
Well, so that's happening. And again, so that builds into my point before that I remember being approached by Veridium several years ago, and my questions were, okay, you're a biometric company, got it, but what more are you doing? And my two questions are, you cannot go in with a biometric solution. You've got to have a platform. You've got to plug into existing identity systems, okay? The second thing was security, right? How is this secured? And when I heard that they had been working with the IEEE on a standard, it's known as IEEE 2410, or the Biometric Open Protocol Standard. That's the API you're talking about. There are register and enroll. This is an open protocol. You can find it on the web. So it's an API, right? You have a client, the server. There are enrollment APIs. There are authentication APIs. And now, in fairness, and we are working this next year for FIDO certification, the FIDO Alliance has an API as well. Okay, and that has its client server side. There are toolkits. There's a server-side API. So this is happening. Standards are advancing, right?
Yeah.
So we're not in that proprietary.
Well, you know what I'm learning right now?
Companies, yeah.
I think the thing that's brought me the most value to this conversation is that you can say the phrase IEEE. Like, I'm over 30, and every time I've seen that, I'm like, IEEE.
Yeah.
I don't hear people talk about it. I don't go to like the meetings or anything, but God, that's so much easier. Every time I've read that in my life, my brain says IEEE or whatever it is. You could just say IEEE.
There you go.
That's so much easier.
Oh, well, you can thank them for that. And that's the academic background, because that's where academics publish, one of the venues for publishing there. So,
how many people do you have right now at the company?
So we have about 70 people in parts of the world. As I said, New York, Boston, London, and Bucharest, Romania.
Ooh.
We have a team. So, and
how many engineering?
Engineering wise, out of the 70, it's probably about, I haven't taken account lately, but probably 45. Yeah.
Oh, okay. So you're mostly engineering.
Yeah, quite. So we have a biometric team, and then our mobile and server teams, right? So it's, and the rest is Salesforce and leadership. And we're very busy at the moment because, as I said, as you demonstrated, biometrics have come of age. We have these, I call them supercomputers in our pockets. They're only going to get better. And in fact, I will say, it's going to get better than what you're thinking. And I'm going to test you. I'm going to test you.
Nope. You're not going to win this one, my friend. I understand that humans think,
go ahead.
Humans think linearly in a linear fashion, but technology advances exponentially.
Okay.
So if I'm going to if you go talk to a human, our default program state is, what's going to happen in the next 5 years? We look back 10, we kind of divide, and we estimate forward. Incorrect, my friend. That's linear thinking. Mm-hmm. Technology advances exponentially.
That's right.
I think it's way, like, everyone else around me is like, no. I've argued with people about, like, voice isn't the future. Like, 2 years later, it is. And it's just because whatever you can look in society, like, for example, with the Alexa thing, I saw my hairdresser. She says her new best friend's Alexa. I had not had a voice assistant or anything like that. I was like, really? Because, like, are those things advanced? Like, do they work good enough? Because I tried them a long time ago and they were like subpar at best.
Oh, totally, yeah.
Yeah, and she's like, no, it's great. She's like, it's her best friend. She can tell her jokes. She can play stuff. So I went home or I went to Best Buy and I got one. And they said, yeah, this thing was like sold off the shelves. Like, we've never been so unprepared. And that was like last Christmas. So that was a year ago. And this whole past year, I've fallen in love with Alexa. Like, I use her for so much stuff. She turns on my lights, my automation, she could do any order. I order stuff, like when I would need to reorder things on Amazon. Like, so useful.
So there's a case in point of how does Alexa identify us, right? So you used your phone, for example, with Face ID, that on your iPhone to use Face ID, making your life more convenient. But that was still an explicit authentication session, right? Yeah. So you paused, you showed your face and so forth. And that will continue to play a role for strong authentication and sessions where you're doing some, let's say you're transferring a large bank amount of money, not me, but money in your podcast guru bank account, and or doing some I was saying some credential reset. Okay, but in the near future, our phones, our devices like Alexa, are going to get really good. I had to admit this to myself. They're going to get really good at knowing it's you.
Oh yeah.
Continuously and in the background. So again, pulling that ubiquitous computing theme up. It's not going to wait for these explicit sessions, right?
It doesn't today. You want to hear something creepy?
Yeah. So yeah.
We have one out in the center of the office.
Mm-hmm.
And the other day we're just like, play Heidi's favorite music. And it started playing the music that Heidi suggests. Like we never set Heidi up. Like we never set the people, it learns the people that are speaking in the area around it, and it will learn their names when you're talking to them. It'll learn all this stuff. And then when they start suggesting songs, it'll develop profiles based on their interest. We never set up a profile for anybody. The only thing I've ever done is just plugged it in and hooked it to my Amazon account.
Right. So this is where there are several names for this now. So either behavioral biometrics or continuous authentication or adaptive authentication or behavioral authentication, right? These are all current terms. Our own product in first quarter of next year, so 2019, we have added behavioral biometrics. So that allows you to conduct longer authenticated sessions without having to fall back to explicit biometric authentication, because your phone will be able to know that, you know, it's still you using it from your last authentication session, okay? And there's various ways of doing that, including, you know, the gate, right? Movement of the device, geolocation, other thing, learning that it is actually you. If it is in doubt at all, right, that it's you, it will call for an explicit authentication session, right? And ask you to authenticate in order to bump that up. But that's coming next year. And in fact, it's already in many products. Our product, the first quarter, behavioral biometrics, we call it, or user behavioral authentication.
You know where you can see that today already.
Go ahead.
Popping ideas into my head, my friend. When I travel, my visa yells at me. Boom, fraud. I land in San Francisco. I'm in Florida. Fraud. You're not in San Francisco.
I love it. I have American Express. I do the same thing. I count on it. I use that for, I would love to see the positive confirmation of a purchase, right?
Yeah.
So, you know, I get a feeling of confidence through these sorts of things. Yeah, we're already seeing that there are privacy implications involved, obviously, that location tracking, use of that to ad tracking. I definitely have concerns, but we have an answer to that.
Yeah. See, and you know what? I've gone, as I've gotten older, I lean on convenience. Like, I'm like, I don't care. Like all this, here's the thing, the amount of value it brings me for it to know all this stuff about me is greater than the amount that like I care if the government knows where I am. Like, I don't care. Like, I just don't care.
But what if I told you that actually that value, there could be even more value involved in that, right? So this is one of the issues that I'm not a legal person. I'm a technical person like you, a technical background. What if I told you that your data is actually more valuable than that value you're getting now?
Pay me for it.
There you go. Right. So we looked at how could we transition, you know, so we allow our biometric product, you can configure the authentication sessions to keep your biometric data on your phone or device using the native authenticator, for example. It's locked into the phone. It can't, you know, be extracted. That biometric data can't be extracted from the phone. We also have configuration for those organizations that need to do biometric comparison on a server, okay? Governments, law enforcement, and so forth. We do have customers in that area that need to do there. That's specialized type of needs. But even in that case, you know, a siloed database of biometric data has to be very carefully protected. And how could you get away from that? How could you, you know, what is the other choice? Okay, biometric data on the user's device, or biometric data on the server. There is a third choice now, and that third choice. So we joined up with
cloud. I'm gonna cry. I'm just kidding.
No, not necessarily. You can still keep it on your own device, but there's this movement that we are promoting that's coming down, like called self-sovereign identity. Have you heard this term?
No.
So I would. This is hopefully this is another benefit to your listeners. So the ability for you to control your own data. So let's put this in the context of a data breach in general, right?
Yeah.
How would you not keep sensitive data of any sort, medical records, so forth, on a siloed database that is probably going to get breached at some point anyway, okay?
Will get breached.
And spread it, that's right, and spread it out so that you actually retain ownership, right? You keep control of that data. Now, it has, for example, been blessed, signed, encrypted properly, whatever. There's several schemas of this. But you actually can keep it. You can keep it on your device. You can keep it in the cloud. There's a concept called a cloud wallet that's being advanced by an organization called the Decentralized Identity Foundation.
That sounds like I trust it.
There you go. So the Decentralized Identity, the DIF.
There we go.
Yeah, the DIF. So we are a DIF member. That is putting you back in control, holding that information. Now, we're not alone in this. We didn't pioneer the concept, but we are definitely promoting this as the
next the future.
Next step in evolution.
I can tell you right now.
Control. Now, the way in which, so the idea would be just like you can now, if I were to give you my driver's license, Joel, right?
Yep.
And you were to look at it. Okay, you would probably tilt it to see the holographic stuff. You'd examine, you know, we're not experts, obviously, like at the airport where they put the UV light. You may even have one to do that. But that's between two parties, right? Me and you. You look at that credential and you trust it to a point, right? To say, okay, this is who he is, and it says he lives here, the picture matches and so forth. Only two parties. What do we have on the web right now? When you do something like log in with Google, log in with Facebook, log in with, you have three parties, okay? You have you, what's called the relying party, the site you're trying to get into, and then the IDP, called the identity provider, right? Like Google or Facebook or Twitter. What if I told you that self-sovereign identity will allow you to do that former thing where it's just me and you, and that's it? So that's coming. That's what self-sovereign identity is trying to enable on the web. And to do so for even critical credentials that are going to be digitized in the near future. So passports and driver's license are still physical documents, right? We have not gone that last step.
We haven't, yeah.
But it's coming. So I point your listeners to projects by the Department of Homeland Security here in the US. There are other efforts worldwide that actually are working on this. Some of the work is under self-sovereign identity, so that you own and control your own identity credentials. Now, the trick is, and I'm going to say a buzzword here, but don't be afraid, how trust is established between you and me when I hand you a digital credential. You do have to check another party, but that party can be offline. And basically, when I was issued it by a government, they actually signed it, and they essentially put like the public key and the signature on a blockchain. That's the way the information gets from the issuer to know that you can trust the credential I gave you. And again, we did not pioneer this. This work has been going on for more than 3 years. It's been funded by DHS, organizations like the Decentralized Identity Foundation, and we are part of an organization called Sovrin, S-O-V-R-I-N, so sovrin.org. It actually operates, so it's an operationalization of this. It actually has a blockchain dedicated only to blockchain identity and digital identity. And we are the only biometric authentication company, actually, as a founding steward. They're called stewards. Those are the ones operating nodes. That is the next step in evolution, right? That we can get past these breaches, not only now have biometric authentication, but now get away from the breaches by, it's called spreading out the attack surface, right? If your credentials are with you and me and so forth, it's not in some silo where you break into the castle and you get access to everything, millions of records, right? If I were to spread out the attack surface, that's much more resilient, right, to attack than having a single silo. I like to think nowadays we live in a mainframe era of web services, right? You do remember, you don't remember mainframes, but
oh no, I do. I want to see where you're going.
Well, the idea being, when you use any large web service, even though it's a large cluster of computers, you can think of it, it is one big silo of data. And we used to do this 30 years ago with big, and we got away from that through personal computing. Well, another wave is coming where we won't have those silos anymore, but we will be able to establish trust between all of our individual devices that manage this. Now, a lot of it will happen in the cloud, but it will be provisioned differently.
So like, let's not stop there at all. Let's keep going. I want to know like how it would look, because my background's developing applications, right? So like,
okay,
let's say that let's just stick with a really simple concept of like a bank, right?
Mm-hmm.
You get a bank has like all my information. They have like my driver's license, my social security. They're a big silo waiting to be attacked, right?
Yep.
Now they need that information in order to have like to authenticate with. They need that information, right? Like I have to give it to them. They have to have it on file somewhere. So like, how do they have the information, but it not of, and then have the information of millions of people, but it not be in a silo?
So without diving so deep on self-sovereign identity, which is its own other topic, I would go to an issuer, okay, maybe that bank initially, and I would provide that type of information. And you can actually provide it digitally through these digital credentials. But you have to think that information should really be ephemeral, in the sense that
100%.
After I provide it, okay, they could get rid of it, okay? And they've issued me credentials such that when I approach them later, or even if it's portable, I approach them with a credential that I control, and that word control is important, and it has to do with controlling a private key.
Let's do it. I'm sold. I already got it. Let's make storing personal data illegal.
GDPR in Europe is making a step toward that, right? So if you think about GDPR, now let's keep biometric data because that comes under GDPR. If you read that legislation in Europe, it is saying if you don't absolutely need it, you cannot store it. It must be ephemeral. You must have a compelling reason for storing it. That's part of the GDPR legislation.
Okay.
If a company is breached and that data is lost and it is not found to be in that, if it's data they should not have kept, the fines are what? I mean, I think it's upwards of 20% of revenues or something for that company. I mean, it's quite punitive. So they want to. I've never met a company yet that doesn't. They do not want to hold this, right, long term. They would like to de-risk, right, by not holding that, including biometric data. They don't want to hold that. So it should be ephemeral at best, and it could be used. But I think your question is, how down the line, when I return to them to do operations, do they continue to have that confidence in subsequent authentication? Or, one thing that occurred to me several months ago is banks not only have to do, they call it know your customer type of operation. So you sign up for an account. That's what you're talking about. That's not just an upfront activity and then you have an account and they stop. They are obligated in most jurisdictions around the world to do continual anti-money laundering checks and these sorts of things, right? They could do this by getting rid of the ephemeral data and using those digital credentials that you have to supply should you need some subsequent verification of your identity. And then finally, if you're holding that digital credential, and again, your listeners and so forth, look at some of the work on self-sovereign identity on the sovereign network itself, that the tough nut is to, how do I associate that digital credential that I'm handing you? So it's been cryptologically signed. You as the relying party that needs to trust me can check that. But how do you know that I actually unlocked like the private key to prove that I control those credentials? That is best done biometrically, right? You can do that through passwords and so forth, but the binding, what's called verification of identity, that the subject actually providing the digital credential is the person you're currently operating with in the area, that is actually the great unsolved problem at the moment, open to most disruption.
State the great.
Did you understand that?
just in the most simple fashion, state the actual problem.
So right now, public key encryption. You're pretty straightforward with that, right?
Yep.
So if I have a public key published by you, and I say, Joel, I send you a challenge. I encrypt something with the public key. I send you the challenge. What do?
I decrypt it.
You decrypt it with the private key. You might then sign something, send it back. I decrypt it with the public key. I'm sorry, make sure you encrypt it with the private key. I decrypt it when I get the challenge answer back with your public key that I have access to. And that establishes that level of trust, right? Yeah. Okay? Okay. Now, the last link that really hasn't been solved is, how do I know it's you that control the access to that private key? Somebody could have stolen your password, right? If you lock it with a password, or unlocked it with your phone on. You see the problem? The problem is the subject. How do I know you, literally as a subject, control that private key? Possession of device is one thing, right? The fact you possess a device that has the private key. But that's only part of the solution, right? How do I strongly bind your ability to control that private key with you?
Okay? Yeah, you just have to add a new feature to it. You'd have to make a new system. I mean, you'd have to modify it to include.
So, but that's what our biometric solution does. We rely on public key encryption. We have a private key, but control of that is unlocked by your biometric. FIDO approaches it the same, and so does Face ID and Touch ID on Apple devices and Samsung devices with Samsung Fingerprint. They all rely on the biometric unlocking that private key. But the key there is, how do you know that the actual unlocking, right, was done by the subject who initially enrolled that key pair in the first place? It's a subtle nuance, but biometrics are one of the strongest ways of binding that.
Yeah, you have to use biometrics when you're building that whole process to begin with. It has to be has to be embedded in its root.
That exists. So the whole reason for our solution, FIDO's solution, is to strongly bind that, control the private key, okay, on a device to you. Not just possession, right? Not just the fact you have the phone and therefore can exercise the private key in the fashion we just talked about. So,
yeah, I'm sure some of the people with all that Bitcoin wouldn't mind that too much.
I'm sorry?
I'm sure all the people with the Bitcoin wouldn't mind it too much.
Well, certainly that's, so Bitcoin is a marvelous type of, I often compare it to using the road. Oh, Bitcoin is used by bad guys. And I said, well, so are the public roads, right? So don't blame the technology. It is a technology. How we use it is.
No, they're not. Bad guys aren't allowed on the roads. They just walk into the jail and they just.
Last time I checked, police were still chasing people down the road or something.
Okay, you got me there. I guess they do exist in public.
So it's not the fault of the road, right? The road has used. It's the same with Bitcoin. And no, you're right. But the problem with Bitcoin and other cryptocurrencies is use, how do I control those private keys and how do I manage them properly, right? People have panicked at
you write them down
at the thoughts of what. Yeah. So this gets us to a good point. So it comes down to public key cryptography and able to secure the infrastructure, right? So I talked about end-to-end. It's reliant on good, strong cryptography. But binding the subject who controls the private keys, that is a challenge, and that's typically done through biometrics. Now, what happens?
That's what your company solves, right?
That's what our company solves. So and not just for Bitcoin and stuff like that, but I'm saying for just the control of the private keys for authentication and identity verification. But what if you lose those private keys? Right? What if you lose them?
Yeah, you need some sort of restoration process.
Recovery, right? Yeah. So recovery. So I recall a few months ago being at a conference, and a guy from Google, his name is Grant Dasher, got up. And Grant is one of the people behind the new the Google Strong Authentication work.
And he's got a cool name.
Yeah, he's got a really cool name, and he's really smart. And Grant said in this talk, since instituting strong second factor authentication, we have not had a problem with phishing at Google. Not one, zero. They, however, say we encourage longer sessions, adaptive authentication, making sure it's you based on your usage patterns and so forth, just like I said a couple minutes ago about behavioral biometrics. But where there are still issues are what they call bootstrapping, like onboarding, and account recovery. Those are open, right, to hacking. Those are the cracks in how does this person who may have lost all their private keys, the slip of paper with the fancy words that you wrote down to recover, right? You just said, what if I lose all of those? All I've got left.
I had it in my wallet, and then I lost my wallet.
So a digital wallet or a real wallet?
No, I just said, like, when you were talking about writing everything down, I remember my dad's wallet used to be like 3-4 inches thick. I was like, you're gonna get scoliosis sitting down on that wallet.
Oh, the Costanza wallet, yeah.
Yeah, the Costanza wallet, and he had like all his passwords in it, and it like would write it down, and that was like the 80s.
God's sake, yeah. No, this is crazy. So in the end, we have ourselves to present, right?
Yeah.
And even if we're incapacitated, God forbid, that we have ourselves, biometric recovery and the ability to use that to recover, right, or reestablish key pairs. Typically, in things like self-sovereign identity, the way it's done is you obviously don't recover those private keys, but that key is revoked, right? So it's basically on a revocation list, and you're reissued, okay? But the ability to revoke, I mean, that is authoritative in a sense, right? You've got to go zero out those keys, put them on a blacklist. Several blockchains have a way of doing this. But to do so is a very strong activity and can be bound to the biometric, right? So you can say, yes, we can prove, using fingerprint, face, voice, whatever biometric mode or modalities to establish you had control of those, and we will revoke those and reestablish new private keys associated. That is the self-sovereign identity way of account recovery.
How do you handle identical twins?
So, interesting you should say that, because all biometrics are not created equal. So here's my little biometric spiel.
Okay.
Again, I'm not a biometric scientist. I came to this.
We will hold you accountable at the level of a scientist, though.
Obviously. So yes. Not all biometrics are created equal. Face is actually one of the weaker biometrics, right?
Can you tell the difference in DNA between identical twins?
So on a scale, roughly in my head, Joel, face is at about a 25% mark. Now, with Face ID, what Apple has done is to put very fancy hardware, the dot sensor and so forth, to give them more than just your face image, right? You get a 3D picture and so forth. Those are necessary because face is rather weak. Up the scale, from there is fingerprint, okay, which is probably about a 90% level. It really jumped from face up. So fingerprint, iris is slightly above that, and then DNA could be even further above that. The problem is that to do iris, right, and by the way, fingerprint, iris, and DNA, of those, I'm 100% sure, because I just read the other day, iris is different even across twins, across identical twins.
Okay.
The issue there is most of those, except fingerprint, require special hardware, right? And for the most part, you are not going to be able to equip all phones, at least probably in the next 10 years, with special iris and, God forbid, DNA type of adapters. I don't even see that right now in the market. But our solution right now works even for 2 or 3 generation phones for fingerprint acquisition. We basically take a picture of your hand, right? And we extract the fingerprint data. It works across Android and iOS devices. And it can extract up to 150 features per finger, which is highly distinctive across, if it's all 8 fingers, it's a trillion people, which is way more than the current population of the planet, obviously. So if you get that level of distinction, right, with 8 fingers, you can reestablish with a large degree of confidence, even in a population of identical twins. So
that's interesting.
Yeah. But that's only in cases you wouldn't, for example, require 8 fingers, right, for authentication purposes. That's inconvenient. For things like account bootstrapping and recovery processes, to get that degree of confidence to reissue keys or even revoke old keys on behalf of the user, they might not even be aware that keys are involved in the background, right? And so we're talking techie to techie here, right? People shouldn't have to worry about that type of mode, and that's public key encryption has had that problem of making it convenient but hidden from users, right? And I think one of the last ways of getting that working is really biometrics, right? Because that enables people to use a convenient mode, but to get the confidence of the underlying cryptography foundation.
I like it.
Well, this is coming. This is why I joined the company as CTO, because the time is right. I mean, this is happening now and very quickly. And as evidence, you don't even have to look at the biometric evidence. The complexity of passwords, right? The baroque nature of rules and cycling. If I have to go through another, one of the things that annoys me lately is I put a password in that I think is really strong, even using a password generator, and it gets rejected because it doesn't have enough capitals or special characters. And I'm thinking, this is unbelievable, right? We've reached a breaking point. We have absolutely reached a breaking point. So what's next? And this is why I joined Veridium as CTO.
I love me some LastPass, though.
You know what? I see them as strong gap solutions for the meantime, right? We have a password world. We have a password world. We live in that password world. But, and I'll make a prediction here, I think in 10 years or even less, when I tell my children, okay, they think I lived in a world when they see black and white movies. Oh, was the world black and white? No,
stop it. Have you heard did you hear me talk about that on the show?
No, I didn't.
Oh yeah, when I was a kid, I like in elementary school, I asked my parents, I was like, when did the world get color? Here's the thing. Here's the argument to that. Okay, because I was some consciousness then. Okay. Here's the logic to it. By the way, if your kids are asking that, they're very bright because they're logical.
I can't argue with them.
Because here's why. Well, at least your kid. How old are your kids?
Well, now they're 11 and 14. They're teenagers.
Okay. All right. So I'm like 31, right?
Okay.
And or I'm coming up on 31. That's very soon. But now I'm thinking about age. Anyways, you got me thinking about how I'm getting older. When I was in school, there weren't like really computers. Maybe a couple computers in 3rd or 4th grade. We started to have them a lot. Mm-hmm. But all the pictures we would see of the past are in black and white.
Sure. Okay.
right?
Yeah.
So well, that would be true. Yeah. Well, all the pictures we would see in the past are black and white, because I guess like, color was relatively new in photography and things like that. So we'd go to school and all day I'd look at pictures of the past as black and white. And I'm just like, we'd watch movies as black and white. We'd see pictures as black and white. And then all of a sudden, some of the newer stuff started to have color. And I'm like, when did the world get color?
Yeah. So my point though is, when I tell them now about dialing a phone or playing a record, this is going to happen to you, definitely myself, of course, when you talk about typing in a password.
I know.
Okay. We are going to be, that will be anachronistic, to the point where they won't remember a world in which that happened, right? So we are in a gap, right? So technology like LastPass and so forth are a gap technology, and we need them, to get from here to there.
Yeah.
But I think ultimately long-term convenience and increased security using biometric data, what we are, with the strong foundation of cryptography is going to be that next hurdle, and we're on the cusp of it right now. So
my thumbs will be stronger than my kids, because I'll be so used to have typed like my whole life. And they'll have like Alexa doing
what about
stuff.
the voice? Go back to your Alexa. You don't have to type. Come on. I have a friend now. He literally, I couldn't believe it. He uses transcription all the time.
Yeah. Well, you know what's big in China, and what's becoming big? Here, I'll show you my phone right here. You see this? This little thing in the bottom corner. There's a microphone next to my text message.
Sure. Yep. Mm-hmm.
And I can just be like, "Hey, boo, I love you. Bring us office cookie soon."
There you go.
And then boom, that's it.
So if you brag about your strong fingers, that's going to be like me and my Xerox stories.
I know. I know. I love it. This is a fantastic conversation. I learned so much about security. You're right on the tip of the future, man.
Thank you very much. So, hey, I wish, now it's wonderful to be alive now. It's such an exciting future. So stay in there and stay broad.
Yeah. We're going to make it into the computers though. I think we'll end up going into the computers. I'll just get weird for a second. Look, think about it. If you look at if you stand back like an alien, all right, just pretend you just come across Earth and you hit play on the past 25 years. Mm-hmm. All we've done, it looks like technologies are God. We've built it. We worked for it. We grow it. We improve it. It takes over the world, and we constantly are making it smaller and putting it into our bodies closer and closer every day. Mm-hmm. Well, like, you think that is just going to stop? There's this thing called momentum. That's not going to stop. We're going to completely become ingrained and become one with the computer, and then eventually have the option to like go in it, or like, for example, like teleportation, right? Like, I totally see us being able to just teleport our consciousness. Like, why not? Put it into the computer, put it into a body. Like, why is that not possible?
So have you read Greg Egan? So the science fiction writer Greg Egan. One of his best book is, I'm trying to remember the title. It's been so long since I read it. Anyway, it'll come to me in a moment. But Greg Egan talks about this.
We're already teleporting stuff.
Yeah, and that goes back to my NASA days. One of the things NASA's done fantastic things. It was a privilege working on projects there. One of the projects I worked on was Cassini, the Cassini Saturn mission. Cool. A very sliver of that, but the amount of science produced for the amount of money in those remote missions is incredible. And of course, that was done through telepresence, right? We wouldn't have been able to do that without computer technology and robotics at a distance. And the amount of money we had to spend to get that amount of science, is just a tremendous value, in my opinion. So.
Tech transfer. Did you hear our episode with Douglas Terrier, the CTO of NASA?
No, I'm sorry.
I recommend
I don't know him. Yeah, okay. I'll have to
he's
go
awesome.
back on that.
Yeah, we talk about the concept of tech transfer, how technology is innovated by government. Like, for example, we got power tools from the space stations and stuff, and how technology transfers from the private to public, or from the government to the public sector.
Sure. I remember witnessing this with the internet itself. And I can say I didn't invent
Yeah.
it, but I was there when it happened. I did have an ARPA.net account. So,
Did you?
oh yeah.
Who's that famous politician that like takes credit for the internet all the
Oh,
time?
Al Gore, Al
Yeah,
Gore.
you were in the room with Al Gore. You didn't create it yourself, but you were in the room.
I wasn't even up that high up the ladder. I was just a graduate student, early graduate student at that point. So,
Okay, John, as we wrap up, what is some advice you would give yourself if you could teleport back 10 years?
uh, take that offer of employee number 13 at Adobe, and instead of going to graduate school. No, seriously, that happened to me. I say, okay, your girlfriend will wait, and and you can go back for your graduate degree. No regrets there. Besides the obvious things in hindsight, I'm not sure I would say do anything. I would just say have confidence, stay in it, learn lots of things. As a technical person, I think communicate more. I think one of the things I like about the role I'm doing now is I do get to evangelize, talk with people like you. Technical people, we love to come in, hack for hours and hours, and then go home. That's how we recharge. But I think it would be communicate more. And that's what I would say. So jump into open source projects even more, right? Contribute regardless of what level of skill you have. There's always need for QA and documentation type of things, or testers on even mainline projects, on GitHub or something. I would say, jump in more on those type of efforts. So, and that's to a technologist. To people who are non-technical, similar advice: just jump into these things, right? And engage yourself. Don't be afraid. Yes, there will be trolls that will, why did you do that? And oh, you did that pull request wrong, la la la. Trust me, there's more good people that are patient, that will help you, than there are those trolls trying to shoot you down out there on GitHub and other open source projects. So
That's some good advice too. I've actually told some of the new programmers, like, be careful on Stack Overflow. Like that's not an accurate representation of everybody, because sometimes people are really mean on Stack.
That's just inappropriate. We need to be welcoming. We need to reach out to on such projects, and really be very, very open to all types of people on those projects.
Nice. So almost 13th employee at Adobe, close to Eric, right?
No. I don't know. I mean, I've talked to him once.
You were close to his office. You were close. You walked by his office, right? All of these. I think this is your time to shine, man. I think, John, I think this opportunity that you're in right now with the biometrics, I think it's the right time. I think you're going to end up as 20,000 employees right at the company, and I hope you'll still come on the show and answer my emails.
It'd be a pleasure, Joel. Thank you. No, I hope we grow. I think the time is right, but we'll always work hard to keep those biometrics private and keep authentication and identity strong. So,
fantastic. If you need anything from me anytime, you just reach out. I'm always available. And yeah, the show will air in a couple weeks.